traditionally, people have talked about dopamine as a reward, but in reality, it largely drives motivation. The brain is pretty good at deciding how much it needs as long as you give it the opportunity to do that.
Do you pick inefficient brain exercise or activities for your brain to help it grow?
Social context is a particularly big driver of dopamine changes because we know that our social environment is so important to our survival, right, as a species.
Yay. Hello, I'm Dr. William Morgan, president of Parker University, and today I have a very special guest, Dr. Tommy Wood. Tommy, thanks for joining us.
Thanks so much for having me. It's a pleasure to be here.
So you got a pretty interesting background and pretty interesting pedigree about your education. So tell us a little bit about yourself.
My primary job is as a neuroscientist. I study ways to treat the injured brain, but I also do a lot of work in elite human performance, particularly in motorsports with Formula One drivers, but some other professional sports, basketball, football, and then sort of translate that arc through to the end of life, looking at different ways to support cognitive function and prevent cognitive decline.
Yay. So you've got a book coming out. What's the name of that book?
It's called The Stimulated Mind. It will come out early 2026 in March.
And we're looking forward to it. So we talk a lot about brain health, body health, and how to stimulate the body and our brains to live 20 more good years or have a healthy aging of our brains. And you've got a lot of studies in this, and you've studied sleep, exercise, caffeine use, and many other things. So what advice would you give to someone who wants to make sure that they have good cognitive ability as they age?
I think, and the premise of my book and a lot of the work that I've done is that the function of the brain is stimulus driven. So the primary determinant of how well our brains function is how we use them. So if you want to have 20 additional good years of cognitive function, the most important thing you need to do is challenge yourself cognitively. And we see from several studies that the amount of cognitive engagement that somebody has really determines at least the slope of their cognitive change with age. There's a lot of evidence now that actually cognitive function doesn't need to decline as we get older. Part of the reason why it declines on average is because we think it should decline. We stop doing difficult things and then it declines as a result. But if you can continue to engage in learning new skills, social activities, cognitively difficult or stimulating work with problem solving and social interaction, actually you can sustain normal levels of cognitive function ideally until the end of life.
That goes in the face of our natural propensity to seek the easy route or the well-traveled path that's easier to drive down. Is that true?
Yes, I think sort of one of the basic tenets of human evolution and human physiology is that we have lived hard lives as our species. We've had to do difficult things, but now if you don't have to do that, right, you don't have to move, you don't have to do physical activity, you don't have to hunt for your food. That is our biology sort of wants us or drives us to do less, because it's like, why would you do something that's energetically expensive or difficult if you don't have to? And so that's where our modern environment is really creating this scenario. We don't have to do difficult things, but the problem is that our body expects it. So the function of our physiology is directly connected to the stimulus that we apply to it. So physical activity is a core requirement of normal physical function, just like cognitive stimulation is a core requirement of brain function. But our evolutionary biology kind of drives us to take the easy way out and just watch TV and sit there and snack and not do physical activity. So now, in order to give ourselves the inputs that we require to function, we have to go out and seek these sort of opportunities to do difficult things so that we can continue to improve and maintain function.
So you have to create friction to create that stimulus.
Yeah.
It's like working out. When you work out with weights, you pick inefficient exercises that stimulate your muscles to have them grow. Do you pick inefficient brain exercises or activities for your brain to help it grow?
So the only way to challenge or drive new adaptation in the brain is to create a scenario where you essentially fail, where there's a difference between what you're trying to achieve and what you're actually achieving. So that's what really drives the biggest driver of neuroplasticity in the brain is this mismatch between what you're trying to do and what you're actually doing, right? Because if you can do something easily, there's no driver for change, right? I've already got these networks. I don't need to create anything new. But when you fail at something, all right, there's this thing called error-related negativity. You can measure it, like the electrical activity in the brain. That's the brain saying, oh, I actually can't do this. And that's what switches on neuroplasticity. That's what then allows you to create new connections, is that process of failure. So it's almost like you talked about inefficiencies, but it's almost like creating this opportunity for your brain to see, oh, hey, here's where I want to be, but I'm not there yet. And then that is what drives that sort of process of development. And you can see that in terms of brain function, brain structure. So actually one of the best drivers of learning is failure, right? Failing to remember the material properly. That's actually one of the best ways to then remember it later. What's interesting then, as an educator, the education system in general has basically creates a cost from failure, right? We don't want to fail. Students don't want to fail, but they don't realize that actually being put in a position where they can fail, that's actually a really good stimulus for learning in neuroplasticity.
So I remember some things I failed in when I was in college that I remember today. I will never forget them now. So along with it, we look at an Aboriginal young person throwing a spear. Mm-hmm. And it's required for survival. They throw it, they don't get it, but they have to get the skill down. Yeah. They nail it, they get a little reward. So dopamine, is it a reward, or is it a neurotransmitter that helps to learn?
Traditionally, people have talked about dopamine as a reward, but in reality, it largely drives motivation. But there's this, it also kind of like the total dopamine signal over time helps us integrate information. So you get dips in dopamine when you fail at something, when you make a mistake, but you get bumps in dopamine when you succeed. Both of those are important for learning. So it's your brain kind of says, oh yeah, I had this big kind of change in my dopamine signal, either up or down, and then it looks back and says, well, what were the things that happened that drove that change in dopamine, and then that's what drives learning. So everybody's always talking about more dopamine for learning and more dopamine for motivation, but actually dopamine dips, particularly when we make mistakes for things that we want to get better at, those are equally important for driving learning. So it's kind of the brain integrating, trying to achieve something, and then whether it was successful or not.
And my understanding is Las Vegas and like slot machines, they work on that thing that the Aboriginal man throwing the spear he gets the lows and the highs, the dopamine, but he's learning the skill. He gets rewarded every time he gets it right.
Yeah.
But Las Vegas, these casinos use that same thing to trick you into think you're getting the skill.
Yeah.
You get the same reward as you would have gotten if you could nail the spear, but it's totally chance.
Yeah.
So you get stuck in this cycle of just gambling away your money because it's using this primeval system that your brain has to become a better spear thrower.
Yeah. So your brain is driven to learn, right? You watch a developing brain in a kid, right? They're desperate to interact with the environment and learn new things and try things and fail, right? Kids when they're trying to walk, they're trying to stand up, they make mistakes, they fall over, and then they do it again. And so there's this like core requirement of the brain to go out and try and learn new things. If we put it in the right environment. But like that is exactly leveraged. Well, it's leveraged in Las Vegas, it's leveraged in social media. Social context is a particularly big driver of dopamine changes because we know that our social environment is so important to our survival, right, as a species. So our body is really primed to look for social cues. So social media is particularly good at leveraging that. So what you see with slot machines is kind of amped up in the social media setting because we, as a species, our brains really prioritize social information, which kind of drives even bigger responses in the system.
So it's even a more addictive response than a slot machine
because it's related to this social environment, which we think is really important.
So we also know that social interactions is important for maintaining health and brain health as we age. So somewhere in between there, is social media like a false narrative compared to you and I interacting together?
It's when you look across all the different ways that technology might affect social interaction, what you see is that if a technology, and it could be social media, right? It could be Facebook or any kind of messaging platform, Instagram even. If it's providing a new way to connect with others above what you're already doing, and it's a new sort of stimulus, then it's potentially a net positive. So if you take, say, older adults who've never used Facebook before, and you give them Facebook and it allows them to connect with their family, that's associated with improvements in cognitive function. It's a new social stimulus that can be beneficial. But when you look at individuals who only, who are younger, who only have social interactions through social media, then it's a net negative because you're removing that in-person social connection that's really important. So it's not that it's good or bad. It's just that how, what is it doing relative to all the other social inputs that are really important? So if it's giving you new social connections, that's great. But if it's constantly telling you you're not smart enough, pretty enough, fit enough, jacked enough, tan enough, and you don't have any social relationships that are giving you positive inputs, then it's a net negative.
Wow. So you talked about sleep, caffeine, getting swole, getting jacked. So which of the, I mean, they all play into this. Now, some of my friends, I'm getting at that stage where most of my friends are retired. And I could almost see that they couldn't wait to get to the place where they could just sit in that chair and watch TV and not be held to a higher standard for fitness or work. It's almost like it's like a self-fulfilling prophecy that you are in that rocking chair because you anticipated being in the rocking chair.
Yeah.
How do we go ahead and take those years from 65 to 85 and maximize them? What 5 things would you recommend we do?
So I think the first thing really is that mindset that you talked about. Now, of course, if all you want to do is sit in a chair and watch TV and you don't mind that you're going to rapidly decline because of that, that's fine. I'm not going to judge that. But that's probably not what most people would want. But so the first thing that you need, the first thing is realizing that doesn't have to be the case. So stereotype, when we think about aging, this is the idea of stereotype embodiment theory. That's exactly what you said. I'm getting old, therefore I'm going to lose function. My brain's not going to work well. My knees are going to hurt. I'm going to get injured in the gym, so I shouldn't go. And because you don't do those things, because you think you won't be able to do them because you're older, it's the not doing them that then drives the decline in function. So the first is knowing that if you continue to engage in that stuff, you can enhance or at least maintain function. Then the framework that I have is particularly when it comes to the brain, but it works for the body as well, is this idea of, I call it the 3S model. So it's stimulus, supply, and support. So stimulus, we've already talked about. You need to engage in these difficult things in order to maintain that function. You want your brain to keep functioning, your body to keep functioning. You need to give it difficult things. That's what drives adaptation. Then you can support that process with these other two buckets. So one is supply, which is, so for the brain, it's like blood supply, good metabolic health. So you get glucose and other things delivered to the brain properly. As energy substrate, it's nutrients that the brain needs. And it's the same with muscles, right? You need a supply of protein and these other things to help build muscle mass. And support is the other one, which is you need some period for adaptation to occur. That's where sleep becomes really critical, but also avoiding things that inhibit that adaptation process. So that could be chronic stress is a big one for the brain, as is smoking, excessive alcohol. These kind of prevent that adaptation from occurring. So if you're trying to think about things that you should do, think about like which of those buckets do you maybe have the most to work on? Are you like, if you want your brain to work and you're doing lots of cognitively stimulating stuff, but you're not sleeping, then that's the lack of sleep is preventing you from adapting. Or maybe it's, you don't have enough of the nutrients that your brain needs. So, iron, omega-3, vitamin D, B vitamins, so then thinking about your diet. So I wouldn't give you a list because for each person, it's going to be different, but just thinking about those different buckets and saying like, which of those maybe where do I have the most to benefit? That's probably going to be the main sort of performance anchor that you have. So that's the area that you should focus.
Thank you so much. And when you're talking about like mental stimulation, we're not talking about these brain game apps that they have there. What are you talking about?
Yeah, it's interesting. There is some evidence for brain training games. So I'm not going to like completely throw them under the bus. the biggest study that was ever done that showed that you can use brain training to improve quality of life and cognitive function was called the ACTIVE study. It was a long time ago, but they took more than 1,000 people. They randomized them to different brain training groups. They had a memory training group, they had a reasoning training group, they had a processing speed training group. And these adults in their sort of like 70s plus. And in a short period of time, they did these processing speed. So like the processing speed group tended to do the best, but it was basically stuff would flash up on a screen, and you would have to kind of process the information and recognize patterns and stuff like that. This is enacted in a brain training platform called Brain HQ. They have something called Double Decision, I think, which is the version of this task. Anyway, that group, several years later, they had better quality of life. They maintained sort of activities of daily living compared to other training groups and a control group. So even in older adults,
So it had a lingering effect.
it had a lingering effect over years that they did this processing speed training. So I don't think that brain training is the thing that's going to solve all the problems, but there is some evidence that it can work or it can help. But I mean, what you really want to do is what I think are much more human, cognitively stimulating tasks. So any kind of new skill, particularly if it comes with physical activity. So open skill movements, that's dancing, team sports, ball sports, board sports, anything either with a social component or with a complex coordinative movement component plus a physical component. Like dancing seems to be like the best intervention for the brain at any age, really. But then languages are important, music is important. Any of these sort of core things that only humans do that are cognitively difficult and require coordination of multiple brain networks, coordination of multiple body systems, usually some kind of neuromuscular coordination, and social interaction, anything like that. So volunteering is great, and you have new social connections. You're usually learning a new skill. Those are really the activities that seem to be best for maintaining cognitive function.
But it seems to me like it's a continuum. Like it's not like do this and you expect this. It's reading fiction, international travel,
Yeah,
hard physical exercise,
yeah,
cognitive problem solving, navigation in an unfamiliar area. But there's all these. It starts from one end, but it's a continuum until you're doing brain surgery. But all these add up. So it's not that one thing, but is it all these together, in particular, doing hard things?
So you're right. Like even just reading of any kind, fiction, nonfiction, people who read more tend to have better cognitive function later in life, and there are even reading interventions that can support cognitive function through to very complex, singing and dancing at the same time, right? Which is basically you're using every part of your body and in a coordinated way all at the same time. Racket sports, pickleball. Pickleball actually is really interesting because the scoring is really difficult when you're playing doubles pickleball. So the people who I know who play pickleball, particularly as you get tired, like nobody can remember what the score is because it's a really so it's actually an additional cognitive stimulus on top of the physical stimulus, which is pretty cool. But when they've looked at all these different activities and how they're related to cognitive function later in life, you're right. There's not one thing that does it, right? It's usually the number of cognitively stimulating activities across that entire spectrum. So people who do more different activities tend to have better cognitive function, but that doesn't mean you have to dance. It doesn't mean you have to play pickleball. Anything that feels cognitively challenging to you and enjoyable and that you keep doing, and maybe just a few of those things, that's going to be enough.
So do you do any work with the lymphatic system and the removal of tau proteins with sleep? Are you interested in that at all, or is that something you study?
There's a few different parts of that, and a big reason why sleep is important is because that's when waste clearance happens in the brain. So there are studies looking at the amount of sleep that people have in midlife and then say amyloid and tau burden later in life. And one thing that I think is important is that even later in life, if you improve your sleep, like in your 50s or your 60s, later on you will see a decreased amyloid burden. Or I mean, these studies are associational, right? You look at people's brains and you say, what happens to your sleep in your 50s? And if they're like, oh yeah, I started to sleep a lot better, my kids left home, or maybe I retired or whatever, then those people whose sleep improve even later in life they have lower amyloid burden in the brain. So it's not like you can't do anything about it now. You can always improve your sleep to improve like the accumulation of those kinds of things in the brain. And the lymphatic system is obviously what drives that. However, we kind of become very focused on amyloid and tau because those are sort of classical hallmarks, neuropathological hallmarks of Alzheimer's. But just you have to remember that if you're not clearing amyloid, you're not clearing anything, right? So there's a whole bunch of metabolites that accumulate.
So it might be a biomarker that we're easily to identify. Exactly. That might not even be the thing.
It might not even be the thing. I think it's part of the thing, but you're not clearing recycling neurotransmitters. You're not clearing adenosine, right? There are all these other metabolites that accumulate. So it's just a marker that we focused on, but all waste clearance is going to be important. So even just beyond some of those classical things.
And there's a deep sleep that takes place, and the astrocytes shrink by 60% and allow the cerebrospinal fluid to kind of flush the amyloid plaque and these other metabolites out. And what is that deep sleep, and how long do you have to have that sleep to get the good lymphatic clearance?
The activation of the lymphatic system does seem to be greatest during deep sleep. But what's when you look at, so most of that information comes from mouse studies. When you look at the little bit of information that we have in humans, it seems that lymphatic function is actually on a circadian rhythm. So the lymphatic system starts to expand in the evening as melatonin increases. So you're already preparing for waste clearance in the evening as part of a circadian rhythm. So and they've had people who like did dozens of MRI scans at different times of day to kind of show this, like there's this natural expansion and contraction of the lymphatic system with circadian rhythm. So that's why just in general having alignment of your sleep period with your circadian rhythm is really important, right? That's why, you know, shift work and all these other things can be detrimental, because you're not sleeping when your brain is primed to clear this stuff out. So the brain is pretty good at deciding how much it needs as long as you give it the opportunity to do that. So because there's a lot of people who like try and hack the amount of deep sleep that they get, or they're really interested in creativity, so they try and hack the amount of REM sleep that they get. But actually those two things are really balanced, both in terms of, say, skill learning and adaptation, as well as in terms of waste clearance. So if you think long term, what do we know about the amounts of sleep that people get and, say, something like dementia risk? It's actually quite variable. But if you're consistently getting less than 6 hours of sleep a night, that seems to be associated with a significant increase in dementia risk. So at least 6 hours, and within that you've got like 4 of the average 90-minute cycles that we get during sleep. Most of the deep sleep, or more of the deep sleep, happens earlier in the night. But equally, you get more deep sleep as long as that deep sleep is occurring as during that circadian period when your brain is kind of primed for deep sleep. So
it really needs it.
Yeah. So all of these things kind of have to align. But you know, it's difficult to say you need exactly this amount, but at least 6 hours. And for most people, it's more like 7 to 9. And so within that, you get like 5 to 6 kind of periods of like through the different sleep cycles. And you know, most of that deep sleep happens in the first like 3 or 4 of those.
We talked a little bit about biohacking. What's your opinion of that term? And there's a big movement on how to hack these things versus the substantive changes in your lifestyle that you would like to do. But how do they fit in? Can you get a benefit from hacking, or is that short-term benefit and it's taking shortcuts that's going to lead you worse off than you are?
Yeah, I think where biohacking has potentially been beneficial is that it's almost made lifestyle changes cool. Right? Sleep was never cool until biohacking became a thing. And now like social connection is cool because biohackers are talking about the importance of social connection. So I think there's been some benefit in terms of the overall movement because it's brought attention to these core lifestyle factors that we know are really important for long-term health. But if you're truly like thinking about the hacking, like, can I use technology or supplements to boost function? In general, yes, you can. Often there's trade-offs, right? You're increasing function in one area whilst decreasing function in another. And if you're asking your body or brain for more function at a given period of time, you have to pay that debt later, right? you do something, you drive intense focus or like very high levels of physical performance through a supplement or some kind of exogenous means, you can still achieve that. But then later you're going to need a greater period of recovery to do that. So so in many ways, you're often like robbing Peter to pay Paul. Now, that might be good for you so that you can get the performance that you need, but you just need to know that you're going to pay that back later. So like I like to say there's no biological free lunch. Like you have some pool of what you're capable of, and if you ask for more of it now, then you have less of it later. And that's fine, but that's just the decision that you have to make.
Basic banking.
Yeah.
There's limitation of matter. So one study I saw, this is years ago, that shows that if someone is obese in middle age, they're twice as likely to have Alzheimer's when they're older, even if they lose the weight. Are you familiar with that?
It makes a lot of sense. There's a lot of reasons why that might be the case. Of course, like now with the sort of the increasing rise of like GLP-1 and these other medications, there's a lot of promise that if you can improve metabolic health in those who are overweight or have type 2 diabetes, those things are often related, there may be a neuroprotective effect. So when people have excess, what I would call excess energy availability, right? There's too much energy in the system. So then they're going to have high circulating triglycerides and fatty acids. They're going to have high blood sugar. In that state, we know that the brain ends up atrophying faster. So there's kind of like a U-shaped curve of the amount of energy your body has available and the size of your brain, the volume of your brain inside your skull, a percent of your skull is full of brain. And so if you're at the very low end, you have a smaller brain, you just don't have enough resources. But at the other end, high blood sugar and all those other things, high inflammation that comes with that then also drives a decrease in brain size. So I think that part of the reason why obesity in midlife may then contribute to an increased risk of Alzheimer's long term is because of that. However, I would say that the brain is still capable of adapting, increasing function, increasing volume, even later in life. So if you had a period of time where you're a higher risk, say because of some metabolic disease, I think you can still overcome a lot of that later in life, but it requires engagement in all the things that we've already talked about.
Doing everything. It brings to my last question. How important is it to be jacked to have a healthy brain?
It's actually not that important to be jacked. It's important to be relatively strong and have a reasonable amount of muscle mass. And when you look at big population studies, in general, those who are stronger and they measure grip strength. The higher the grip strength, the lower your risk of dementia. I think in that setting, grip strength is really just a proxy for how you're using your body in the world.
Thank you.
It's not like you can just suddenly go and do a bunch of like grippers and you're going to live longer. You're going to live longer. But in general, if you're of people like you, if you're in the top third to 25% of strength and muscle mass, that's enough, right? Beyond there's diminishing returns. Like you don't need more than that. You just need to be strong enough. You need to have enough muscle. Because most people aren't strong enough and don't have enough muscle. It doesn't require that much work. So there is one study out of the UK Biobank that basically shows that the bigger your biceps, the lower your risk of dementia, which obviously is my favorite study of all time. But in general, you don't need to be that strong or have that much muscle. It's something that everybody can achieve. It's just not something that most people do.
I'm going to go back to the grip strength because that is having a grip strength dynamometer is the easiest thing in the world to test. So that's what you test.
Yeah, exactly.
It's maybe a marker for other aspects of general health.
Yeah.
So when I see longevity specialists and doctors requiring their 60-year-old patients to hang by a pull-up bar for 2 minutes to show, that's their treatment. It's like, that may help, but it may be that it's maybe it's a grip where you fall and you can grab something briefly.
Yeah.
There's no studies that show hanging on a pull-up bar makes you live longer.
No. I think you get better data from the studies that look at leg strength, which makes a lot more sense.
And it does. So if you've got fast legs and strong legs, when you trip, and you will trip, you recover and you don't break your hip.
You don't fall over and break your hip. Yeah.
Thank you so much.
Thank you.
You've been listening to Tommy Wood, and this is Parker University.